Hi, this is part 2 of the section 11 2 notes for Algebra 2 on arithmetic sequences and series. And this is Carl Friedrich Gauss. Carl Friedrich Gauss lived from 1777 until 1855. And I want to tell you a story about when he was 10 years old. When Carl Friedrich Gauss was 10 years old, there were no such things as smartboards or whiteboards or even blackboards. What he had to use was a slate when he was in class. So if a student had a long expression they needed to simplify or a long equation they needed to solve, what they would have to do is do a little bit of the calculations, remember it and erase, and do a little bit more and erase, do a little bit more and erase until finally he could arrive at an answer. Well, one day his teacher needed to have some time to get some of her work done. So she thought she could get the class started on a problem and then she would have some time. So the problem that she wanted the students to do was to add the first 100 digits and give her an answer. So 1 plus 2 plus 3 all the way up to 100. Now, what 10-year-old little Carl Friedrich noticed is that if you add the 1 plus 100, the sum is 101. If you add the 2 plus 99, the sum is 101. 3 and 98 is also 101. So what he thought about was that he has 101 for the sum. He had 100 numbers that he was calculating. But if he multiplied 100 by the 101, that would mean that he's counting each number twice. So he had to divide this product by 2, giving him the total of 50/50, and this is what he turned into his teacher. This leads us to the sum of a finite arithmetic series, which has a formula S sub n is equal to n times the quantity a sub n plus a sub 1 divided by 2. S in this case represents a series, not a sequence. A series is a sequence that's being added together. You're adding the terms together. So in example number 4, we're going to find the sum of the first 30 terms of this arithmetic series. 7 plus 13 plus 19 plus 25 plus and so on. So what I need to know is what is a sub 30? Now the formula for a sub 30 would be a sub 1 plus 29 differences. So I need to know what my difference is. A sub 1 is 7 plus 29 times, it looks like each time I go to the next number, I'm adding 6. So 29 times 6, which would give me 181. Now that only gives me the first term, and I need that, or the 30th term. I need that because S sub n is equal to n times a sub 1 plus a sub n all divided by 2. So now S sub 30 is equal to 30 is n times a sub 1 plus a sub n divided by 2. So I need to simplify this. 2 goes into 30 15 times. So I have 15 times 188, which gives me a grand total of 2,820. That's the sum of my first 30 terms. In example 5, I'm going to consider the arithmetic series negative 24 minus 14 minus 4 plus 6 plus 16 and so on. Remember that my formula is S sub n is equal to n times a sub 1 plus a sub n divided by 2. So in order to get the sum, I need to know a sub n. In order to get a sub n, I need to remember the formula is a sub 1 plus the quantity n minus 1 times d. I need to get d. Well, I can get d because I'm adding 10 each time to get to the next term. So d is equal to 10. So now I need to find a sub n. And a sub n is equal to a sub 1 is negative 24 plus n minus 1 times D. If I simplify this, I end up with A sub n is negative 34 plus 10n. So now I know what A sub n is, which is going to go right up here. So if S sub n is equal to 552, that means 552 is equal to n times A sub 1 is negative 24 plus A sub n is negative 34 plus 10n, and that's all divided by 2. So 552 is equal to n times the quantity, negative 24, and negative 34 is negative 58 plus 10n over 2, which I'm sorry, I made a mistake here, and I'm not going to erase the whole thing. This should be a 574 right here. So 574, there we go. So if I multiply both sides by 2, then I'm going to have 1148 is equal to n times the quantity negative 58 plus 10n. And I want to distribute the n. And when you're trying to solve a quadratic, one of the strategies is that you get 0 on one side, so that's what I'm going to do, and then use the quadratic formula. I'm not going to do the whole quadratic formula here. You remember it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. End up with n is equal to 14. You actually get two answers. You also get n equals negative 8.2. But that doesn't make any sense because n is the number of terms that I have in the sequence. So only a positive number will make sense here. My next question is about Cindy. So Cindy likes to line up her cheese nips before she eats them. The first row has 5 cheese nips. The next row has 7 cheese nips. Every row after the first has 2 more cheese nips than the row before it. Cindy can fit 12 rows of cheese nips on the table. If she eats every cheese nip that's on the table, how many will she eat? So what's happening is she's starting with 5 cheese nips. The next row has 7 cheese nips. And then she has 9 cheese nips, and so on, all the way up to her 12th row. So I'm trying to find the sum, the total number of cheese nips that she's eating, all the cheese nips in every row. So S sub 12 is going to be equal to, remember the formula was S sub n is equal to n times the quantity A sub 1 plus A sub n over 2. So that means S sub 12 is equal to 12 times A sub 1, which is 5, plus A sub n, which I don't know right now, divided by 2. So I'll have to figure out what A sub n is equal to. Now remember, the formula for A sub n is A sub 1 plus n minus 1 times d. So I'm looking for A sub 12. I'm looking for my last row of cheese nips. That would be 5 plus 12 minus 1 times my difference of 2. So that's 5 plus 11 times 2. 22 plus 5 is 27. So her last row of cheese nips has 27 cheese nips in it. So now S sub 12 is equal to 12 times 5 plus 27 over 2. And now I need to simplify this. This is equal to 2 goes into 12 6 times. So 5 plus 27, which is 6 times 32, which means that Cindy will have to eat 192 cheese nuts. That's a lot of cheese nuts.